Good afternoon, ladies and gentlemen, and welcome to the first video lecture for Algebra 1, Green Prairie High School. Today, our objective is that we will simplify expressions using properties of equality and inequality and the commutative, associative, and distributive properties. So the essential question is, how do we simplify equations using equality and inequality? But if you see in that objective, there's a few terms that we haven't in this class defined yet, like commutative, associative, and distributive. So let's go ahead and define those first. Okay, the commutative property states that numbers can be added and multiplied in any order. Okay, so in any order. And to look at an example of this, because sometimes that doesn't just jump out, the true meaning of that doesn't just jump out at you, let's look at an expression A plus B. Well, if we apply this commutative property, then we're saying that A plus B is the same as B plus A. They should be the same thing. And we can actually use a symbol to represent it's the same as here. So instead, let's say A plus B equals, or is the same as, B plus A. Okay? Now, if we want to truly test out this theorem, then we can go ahead and add some numbers. Let's try 2 to represent A and 5 to represent B. So that's just going to turn this into 2 plus 5 is equal to 5 plus 2. So let's test whether these two are truly equal. Okay, 2 plus 5 is 7, and 5 plus 2 is 7. So you see that 7 is indeed equal or the same as 7. So we know that the commutative property holds true. Now let's try multiplication. A times B should be equal to B times A. And we can use the same number representations to actually test this out. So let's apply the numbers. Remember, 2 is A and 5 is B. So we're going to do 2 times 5 should be the same as 5 times 2. Okay, we know 2 times 5 is 10. And 5 times 2 is 10. So the commutative property does also hold for multiplication. And there's an example of that property. Now let's define the associative property. The associative property is a property that states that you can add or, not and, or multiply, regardless of how the numbers are grouped. Okay, so you can add or multiply regardless of how the numbers are grouped. And again, let's look at an example just to be sure that it does apply to what we know of addition and subtraction. Starting with addition, okay, let's use the expression 2 plus 5 in parentheses plus 3. And if the associative property holds, then that should be the same as or equal to 2 plus in parentheses 5 plus 3. Okay, so these should be the same thing. And if we actually work out the problem, 2 plus 5 over here is 7, and then we'll still have a plus 3 there. And then let's do the parentheses on this side. 5 plus 3 over here is 8. Okay, and then we have to simplify one more time. 7 plus 3 is 10. and 8 plus 2 is 10. So it does indeed hold for addition here. They are associative. Okay, addition is associative. Now let's try multiplication. 2 times 3 in parentheses times 4 equals 2 times in parentheses 3 times 4. So if the associative property holds for multiplication, these should be the same thing. Okay, and let's check it out. 2 times 3 is 6. And we're going to have a times 4 left. And then 2 times, and 3 times 4 is 12. On the left-hand side, 6 times 4, 24. And on the right-hand side, 2 times 12, 24. So the associative property does indeed hold for multiplication. All right, one last term to define, and then we'll get on to the meat of this lecture. Last but not least, the distributive property. Okay, the distributive property states that you can multiply each number in a sum and then add them separately to get the same result. And sometimes I know that can be a little confusing, so let's try it with numbers. Why not? Okay, and what it's saying is, if we took this 2 times, in parentheses, 3 plus 5, that should be the same thing if we distribute 2 across the 3 plus 5. So you all have seen distribution before, so let's test it out. If we use this right side and just simplify it with the addition first, then that would be 5 plus 3 is 8, right? And we still have the parentheses and the 2. So 2 times 8 on this side, which simplifies again to 16. But now on the left side here, we're going to distribute. So what we're going to do is multiply this 2 to each number in the sum inside the parentheses. Okay, so first 2 times 3. 2 times 3 is 6. And now we're going to multiply 2 times 5, which is 10, positive 10. Okay, so now we've distributed the 2, and we're just going to finish the equation. 6 plus 10 is 16. So these are indeed equal to each other. 16 is equal to 16, so the distributive property does hold. All right, so let's talk about combining like terms now that we've looked at those properties, okay? So this is going to be combining like terms. Okay, let's say that we had a party and we invited all these smiley faces here. So we have 2 green smiley faces and, or add, 2 yellow smiley faces and 2 blue smiley faces. So there's our expression representing this party. But that's just the people who showed up on time. You know, some people are fashionably late, so let's say that 2 of our green smiley faces came a little late to the party. Okay, these guys showed up a little late. So we're going to add 2 green smiley faces to our party. But then, two of our yellow guys get a call, and they have to go do something. So we're going to subtract, okay, two of these yellow guys here are going to leave, okay? So we're going to subtract or take away 2 yellow. All right, so now we have an expression, and you can see we've got some green guys over here, some green guys over here, and then we have a y here and a y here. We're going to take those terms and combine them, put them together, because g is the same as g, y is the same as y, so we can combine them. Okay. So what we're going to do is circle the things we're combining. Okay. And then I'm going to put over here, combine positive 2g for this one, and positive 2g for this one. Okay. So now our expression is going to be 4g plus 2 yellow plus 2b minus 2 yellow. Okay? And that's once we applied this change, this combined 2g and 2g. Okay. Now we have two more things that are alike. They're like terms. Okay, this 2y here and this minus 2y here. Okay. So now we're going to combine positive 2y and negative 2y. And because we have a positive 2 and a negative 2, they're going to cancel out. And so you just get 4g plus 0y plus 2b. Okay? And this 0y here, this guy, 0 times anything is 0, so it just goes away. So you have 4g plus 2b. And that's our combined like terms. So now let's try one with just numbers. Okay, let's try one with just numbers. So let's say we had an expression that was 10a squared plus 2b plus 13c plus 3a minus 4c plus 5b plus 8. Okay. Given this expression, we want to combine all the like terms in there. Now, this guy right here is an a squared. Okay, don't freak out. We just need to make sure that we find another a squared for him to be paired with. So now I'm going to go through and I'm going to find two things that are alike. Okay, I can see this 2b and there's a 5b over here. So I'm going to circle those guys and we're going to combine them. Okay, combine 2b and 5b. Okay, so once we combine 2b and 5b, our equation will now be, or expression will now be 7b plus 13c plus 3a minus 4c plus 8. Okay, and now we can go try it again. Let's look for two more things that are alike. And I can see this guy and this guy have the same letter C attached to it. So I'm going to combine positive 13c and negative 4c. All right. So now my expression is going to be 10a squared plus 7b plus 9c plus 3a plus 8. Okay. Now we're going to look for a couple more things that we can combine. I have an a squared. That's not a like term, not a like term, not a like term. Okay. We need an a squared to combine. This is not squared. Okay. And not a like term. Let's look at b. b, no like term. That's not a b, that's not a b, that's not a b. How about c? That's not a c, that's not a c. How about a? That's not an a. And there's no other just numbers without variables, so we're all done. And that's going to be my simplified final expression. Okay, simplified final expression. So now that we've taken a look at distribution, at combining like terms, now that we've taken a look at combining like terms, let's define it. So let's define combining like terms. So this is when you add two terms in an equation or expression, with the same variable and exponent. Okay. It's combining like terms. So earlier in this video, we looked at the distributive property. Okay, let's pull it up just to refresh ourselves. Here's the distributive property. Okay, but in here, everything here is numbers. We want to use this distributive property in expressions with a variable. Okay, and so that's what we're going to look at next. Real quickly. Distribution when a variable is involved. So this is going to be the distributive property. Or distribution, as you'll hear me use it. So here's an example we want to take a look at. 3x minus 4 in parentheses. Previously, this guy was a number, but now it's a variable. But we can still use the distributive property because we know it holds true. So what we're going to do is distribute here. So over here as my justifier, I'm going to write distribute 3. Because that's the number we're distributing across this sum. Okay. And then I'm going to go ahead and distribute. 3 times x, it's going to give me 3x. Okay. It's just 3 times x written in a different way. Okay, so 3 times x just give you 3x. And then I have 3 times a negative 4. And that's going to give me negative 12. Make sure you're looking at the whole thing, the sign in front of that number. Okay. So 3 times negative 4, negative 12. And I'm done distributing. That's it. So my final answer, 3x minus 12. Now let's look at one more example, or two more examples really, but we're going to look at this one really closely. Okay. Let's say I have the expression negative 7 minus w plus 2. And we want to distribute that. Well, what I'm going to distribute here as my justifier for the next line, I'm going to distribute